Imagine your data, AI data to be exact. Data comprised of billions of pulses of light that travel over and across the internet, carrying information derived from intelligence that is critical to your business. If your business relies on real-time data delivery arriving at a second's notice, without quick crash or system failure, Supermicro is the clear choice. Delivering extreme performance with Petascale all-flash NVMe storage to support proven architectures for AI and ML workloads, with leading software-defined storage platforms. If you're an enterprise business, government agency, or in the education and research sector building a public cloud, private cloud, or generative AI supercluster, there's only one choice. And that choice can only be exactly the best.
Welcome to this session of the Supermicro Open Storage Summit, the new high-performance computing optimized storage from HPC to AI. I'm Rob Strechay, Managing Director with theCUBE Research and your moderator for this special session. HPC is not new. Supercomputing has been around for decades. One of the most prevalent HPC use cases is simulation and modeling, which includes creating virtual representations of real-world phenomena and scenarios, such as weather, climate, aerodynamics, fluid dynamics, chemistry, physics, biology, and more. Another common HPC use case is artificial intelligence, shocking, machine learning, another shocking one, right? Which involves developing and applying algorithms and systems that can learn from data and perform tasks that require human intelligence, such as image recognition, natural language processing, speech synthesis, recommendation systems, and more. A third common HPC use case is genomics and bioinformatics, which involve analyzing and interpreting the structure and function of RNA, DNA, proteins, and other biological molecules, as well as their interactions and roles in living organisms. A fourth common HPC use case is financial analysis and risk management, which involves performing calculations and simulations to evaluate the performance, profitability, and risk of various financial instruments, portfolios, markets, and scenarios. A fifth HPC use case is media and entertainment, which involves creating, editing, rendering, streaming, and distributing digital content such as movie, games, animations, music, and more. All of these use cases rely on one thing, a massive amount of data that is usually the company's crown jewels of data. And the amount of processing needed on that data requires a special type of storage that can handle workloads of HPC. And today we're going to dig into this. Now, before jumping into the discussion, we would like to let you know a few things about how today is going to go. All the materials from the partners that are on this panel are going to be available on the session link on the registration website on thecube.net. And the speakers will be live on X to take your questions. Just use the hashtag SupermicroStorage2024, all one word, to ask those questions. Now, let me introduce our speakers. First, we have Randy Kreiser, Principal Senior Storage Architect at Supermicro, CJ Newburn, Distinguished Engineer at Nvidia, Balaji Venkateshwaran, VP of Product Management at DDN, and Bill Panos, who's the Product Marketing Manager at Solidigm. Now let's jump into some presentations to get a little grounding on this topic. First, hey CJ, why don't you show us what's going on and really set the stage here.
Happy to do that. Honored to be here. So this is a really exciting time to be alive. And one of the things that characterizes some of what's going on now is the rate at which usage models are changing and evolving. Every couple of years we have radical changes. And that is leading to a need for new infrastructure. And in order to be able to make best use of that, the new technologies are needed and are quickly emerging out of that. So one of the things that would characterize some of the new usage models that we have of late is that they're at a very large scale and that they're also making accesses of increasingly fine granularity. So some of the different applications that we see in this space are LLMs, large language models, GNNs, graph neural networks, and RAG for retrieval augmented generation in the video world. Those new applications really need new infrastructure. they operate at a big scale. So you can see the Supermicro NVLink rack level integration, where that whole rack acts as one GPU, all NVLink connected. So HPC has been around for a while, as you mentioned, and it's not going away. People are saying, it's being displaced by AI, but it's really here to stay. One of the definitions of HPC is to scale up and out with rigor and with performance, and we really need that in working with infrastructure. So, and there's kind of in that space, we're seeing things operate at this rack scale. With things happening in a data center, you need automation to be able to roll out new applications, to be able to have tenants share the infrastructure and so on. And one of the key technologies for that is data processing units, DPUs. There's a lot of innovation that's happening in storage, where we're not just doing file, we're doing objects and key value stores. We're doing things with security and increasing concern over security, as we were talking some before the set here. And increasingly, that's happening at user level and being shared for security reasons across these massive resources are being shared across tenants. So there's kind of a delightful integration that we have up and down the stack among those that are here. Where look at what's happening at a rack level, and so we see that Supermicro is delivering that infrastructure there, both at the rack and with things, new tech inside each of those nodes. There's an integration with storage and how it is that we access that, and down to what's going on with the media. So in software, we're tuning at this rack level. I've been working with, was just looking this last week at one of these rack level things that we have here, and working with our teams to tune those. Increasingly, the GPU is initiating requests directly from the GPU, where each of hundreds of thousands of threads are doing their own accesses. And we're trying to bypass the CPU by moving data directly into and out of the GPU with technologies like GPU direct storage. And Supermicro, again, has done some things, for example, with the PCIe switch to enable that. And we've been partnering with DDN in some work that's been ongoing in bringing onto the DPUs the storage stack to make it more secure, and to use some of the acceleration there, and to increasingly operate at user level for that. And finally, we have higher fine-grained IOPS that we need coming from the media, and Solidigm is an example of what's going on with that. So it's great to see all those playing together.
Yeah, and I think, again, that's really one of the nice things that's going on, is that you have all of this coming together. And I think NVIDIA's really at the pointy end of the spear when it comes to this. And again, these workloads aren't going to get displaced by AI and ML. I think, in fact, they're going to get enhanced as people build those types of applications into those data applications as well, so that they become more complex applications for processing. But definitely. So Balaji, why don't you kind of take us into the storage layer now a little bit more.
Great, thank you, Rob. Great to be here. And just picking up from where CJ left off, really the HPC and also the new world of artificial intelligence and machine learning involves large amounts of data, a variety of data, block, file, object, and really DDN strives and has been doing this for a long time now. Our goal is to make sure we make data management easy and seamless for customers and secure, right? So when a customer is buying a GPU infrastructure, computer infrastructure for their AI and ML application, what DDN wants to do is be the one-stop shop in terms of storage and data management, right? And there are a number of things we've done over the years and continue to do in partnership with everyone that's here. Some of the things are, no matter where the data is generated, right? Edge, cloud, wherever it's generated, and all the way up to the GPU, there's a tremendous opportunity to streamline and optimize that entire flow, right? To make it, to maximize the performance, lower the latency, and really be able to scale it as your data scales. So a number of things we have done, such as being able to automate the data placement and maximize the flash performance underneath it, and Bill will talk more about that. Secure multi-tenancy, which basically is a way to make the most efficient resource utilization in a safe and secure way. So that is a leading edge capability that really optimizes the infrastructure deployment, especially at such a large scale. And being able to support any data type that is involved in the AI pipeline, right? There's block, file, object, right? And as these things scale and more data is thrown into the mix, right? So the DDN infrastructure and the software stack is able to accept any and all data types and work with them to maximize the benefit. One of the leading indicators is are you maximizing your ROI and the resource utilization of the GPU and the compute infrastructure, right? So that's been one of our prime themes. And in collaboration with NVIDIA, CJ knows about that, and Supermicro and Solidigm, what we've been able to demonstrate is the ability to keep GPUs busy through the optimizing the application stack all the way end to end, right? And there are other benefits such as support for BlueField 3 DPU that CJ just talked about that optimizes the infrastructure further and at scale. Support for GPU as a service to maximize the performance delivered from the storage to the GPUs. And also support for future NVIDIA GPUs such as Grace Blackwell. So there's a number of things there that's really exciting.
No, I totally agree. I think that when you start to look at it and how you're going to look to keep the GPUs busy, there are big investment into that organizations are making. Really, and the data types definitely differ across that. Like you said, block, file, and object. So why don't we bring Bill in, and why don't we start to dig into that a little bit as well?
Sure. Well, thanks, Rob. Thanks for having me today. So yeah, I want to talk about a little bit what Solidigm is actually doing at the physical level with our SSDs. And Balaji kind of talked a little bit about the need to keep those just GPUs operational. But there is certain specificity when we talk about the type of media and where it plays with, let's say, as an example, in the AI infrastructure. And I like to think of it as stages, right, within that AI pathway, right? There's different needs along those stages, right? So if you think about it holistically, right, you think about first the subset of data that needs to kind of come in. Well, as you talked about it, whether it's block, file, we try to be agnostic, right, at Solidigm in terms of really the data type. But we understand that it's a fair amount of data that's kind of coming in. It can come in from various sources, right? But that data needs to be augmented, needs to be kind of collected up, right? And collecting it up on that media, you need to think about what does that media need to be? How does it need to be optimized, right? And when you think about the large amount of data that's coming in, it really needs to be optimized around the density per terabyte, right? You need massive scale and capacity per the amount of power that you're consuming to kind of collect that data up, right? And so you really need a high capacity, and you really entertain a lot of sequential writes. So you're looking for a product that has really good performance on sequential writes because it's collecting all that data, and you need high capacity, right, as you bring that data in. The next step after that is you've got to prep that data, right, because you want to use it in your training models and whatnot. When you're doing that prepping, there's a lot of sequential read and writes that are happening. And it happens pretty much real time. You're using the CPU in that case, and you're getting it ready for training, and you're necessarily normalizing that data. You may be setting it up in rows and columns and kind of a tabular format and whatnot. But here you'd look to want to maybe use a product that can do both ingress and egress pretty much the same level in terms of bandwidth performance. We know SSDs generally have a little bit better write or read performance than write performance, but generally you want a drive that can do both very well. And so we can look to maybe a high performance QLC product like our 5430, or possibly our TLC based product, our 5520, which is excellent there. But once we've normalized all that data and sort of set it up into tokens, which is batches of data, if you will, to be used in training. We want to move to that next step, right? Now the training is kind of what we were talking about. CJ mentioned it, and Balaji mentioned it, right? You're operating those GPUs. It's very expensive. You don't want any downtime. And when they're operational, it takes quite a bit of power, right? So here there's a lot of random read and writes that are happening, mostly reads, right? There's a few writes, but you really want a high performance product. Again, you're looking at performance per watt. That's the key metric, okay? And so something like our latest and greatest Gen 5 TLC-based product that you're all well aware of as you're listening to this summit would be an excellent choice for training purposes to keep those GPUs occupied, right? As you trunk through that data, right? The next step you kind of think about is while you're training, you're doing checkpointing as well, right? And what is that? Well, you're necessarily moving off data at that point in your training model, right? That's the whole runtime. You're basically splaying that out to the media, right? And so you have a lot of sequential writes happening. So again, you need a product that has high performance per watt, right? You're looking at maybe a good performing QLC product, or possibly our TLC line of products that we have, right? Checkpointing you can do, it varies. It could be, every hour, every 4 hours. It just varies depending upon customer. But what doesn't go away is that performance that's needed in that capacity, right? Finally, you get kind of to the inference stage. And here you're looking for responses from your completed kind of training model. Again, you're doing a lot of random reads and throughput out, some writes, but mostly random reads in the inference. Here you're looking for performance on capacity and throughput. You're utilizing those GPUs again in the inference place, right? And so again, much like what I've talked about with the training setup and whatnot, you're looking for maybe a high performance TLC-based product that we offer, like the 5520 or our new Gen 5 product that we announced to satisfy that inference condition, right?
Yeah.
And finally, in the last stage, you've collected all this data, you prepped it, you're not throwing it away, right? You've got to offload it, right? You've got to store it and archive it. Here now we switched. We're now back to the density per watt need, right? You're storing massive amounts of data, right? So you really want a high capacity drive, QLC drive, maybe like our 5336, up to 61 terabytes of storage, right, per drive, to basically move that data off to the periphery, right? It may be expensive to store at the core. We want to move that data off. We want to do it quickly. But the other thing you have to think about is you also want to possibly be able to retrieve that data quickly as well, because that's costly if it takes you a lot of time to pull it back in to do retraining or whatnot. So when you look at this thing holistically, you find that there's certain areas within the stage for certain media products that you'll engage with, either with, say, DDN or with NVIDIA or Supermicro as you set up that infrastructure, right? So it isn't a one-size-fits-all. So you kind of have to think about it holistically and look for each of the stages and what the necessary requirements might be. And so you can certainly, as you're thinking about your infrastructure and rolling that out, engage with Supermicro, Solidigm, or DDN, and NVIDIA to kind of help you make those right decisions.
Yeah, I think what's been great has been the fact that you really look at the fact that HPC has been leading the way in this space for quite some time as well, because this, again, doing this kind of stuff is not new to HPC, but it's very new to some people who maybe didn't understand what had, traditional AI and things of that nature, which HPC has kind of solved these problems. But I think what you laid out there was really a nice life cycle for that. So Randy, let's bring this all together, because it's a solution at the end of the day that you're providing for the customer. Why don't you take us through that?
Thank you, Rob. It sure is. As you can see, the prototype solution that we have up there kind of brings everything together that we've talked about with all the partners thus far, right? We're talking about new technologies. We're talking about the ability to bring trillions of all of these threads, as CJ talked about, in all of the modeling and so forth, especially with large language models and so forth, which I see just exploding all over the place. This particular product, again, prototype, it will become a future offering from Supermicro in a collaboration with NVIDIA. But the ability that it brings to the table over today's technology and things like that is the ability to get into the hands of the customer an end result. Whether it's seismic processing to figure out where the next major drill place is going to be for oil, or whether that be medical reasons, right, to find a discovery for cancer or whatever it may be. The ability to take larger models and be able to just compute down to the nth degree to deliver effectively these results. Imagine if we could take weather modeling and be able to create accurate forecasting, right? And so forth. Not that it's horrible today, but it's not always as accurate as we'd like to be, but it's just an example, right, of what is possible, I think, when you get to some of these really large models and so forth. Now, one of the things that I think going forward is a big deal is the energy efficiency and liquid cooling capabilities that Supermicro is bringing to the table here. And the example that we're showing here is a 40% reduction in electrical costs. So you don't have to spin up as many fans and things of that nature, and we're pumping liquid through each of the servers and so forth. And this is key, and it's critical because it also helps with the size of the product that's being deployed in the rack. So you're looking at putting a lot of compute density in a rack where if it were air-cooled, you'd have a small fraction of that, and of course then you're taking up floor space. And then you're powering fans, so you lose that reduction, and so forth. So liquid cooling is becoming a big deal. I've heard that Musk is basically designing his computer rooms around the fact of liquid cooling, and hopefully with our product, right? But it's a big deal, and I think going forward, it's going to become a bigger deal as we're struggle to keep up with the electrical demands. Now, a lot of what we talked about requires, again, and we've mentioned it, Balaji mentioned it, regarding the products that are required, the storage. When you're talking about the capability of 1.8 terabytes a second and so forth, it's a lot. And so these products are all based on PCI Gen 5 today. They'll be Gen 6 in the future. But we've got two different types of products here at the upper half of the slide, NVMe. It's a phased approach. It's a hybrid approach, if you will, two-tiered, if you will. Hard drives on the bottom. And of course, you're always going to probably have hard drives involved because of the fact that you can't get to the capacities that are needed without providing a lower cost solution. So the cache being the NVMe up front, the hard drives being the capacity in the back, can provide for exabytes of capacity. And believe me, we're looking at exabytes now, and we're looking in terms of performance to the NVMe tier in terms of terabytes per second. I can't tell you how many configurations I've done in the last 6 months that have been over a terabyte a second. It's kind of crazy. 2 years ago, no one was talking about anything like that. We were talking about 10 petabytes or a little bit more. Now we're talking about exabytes. We're talking about virtually tens of terabytes per second. Now we have a couple of products here that are represented by the top tier there on the slide with new form factor drives and things like that, EDSFF, E3S drives, and even CXL. All technologies that'll carry us into the future and provide a lot of the performance that's necessary. A lot of software, Balaji and DDN, they're providing a product that can deliver the terabytes a second that we need, and future product that will allow us to scale and so forth. Here is an optimized storage configuration. You can almost, with most of the RFPs I see today, this starts pretty much where you're going to be. Spine and leaf switching, these tend to be very high speed, 400 gigabit pick whether it's going to be InfiniBand or Ethernet. That's dependent upon the customers and so forth. But you see in the lower left-hand corner the HGX systems, and it can be virtually any number. On the right-hand side is the DDN appliance. We're looking at NVMe up front. If we need to put spinning disks behind it to increase the capacity, we have that capability to do that. You've got the management servers and so forth to run, the job schedulers, and the entire HPC compute platform. This is a starting point, and then they can grow, and they can just continue to grow to the point where we're doing the tens of terabytes a second, the exabytes of storage, and the compute necessary to deliver performance for all of these customers that require it.
Yeah, I think that breaks it down just perfectly to help the viewers understand what is needed and what's going to be really put into these systems so they get a feeling, because I think, again, HPC has been leading the way, and AI, in traditional AI and now Gen AI, is just a different application for it. Like you said, the scatter, when you see the weather and the scatter plots and all of that, and I love the lines and how they converge as the data gets better and the epoch gets smaller and stuff of that nature. But let's stay with you on a question, because I think, again, just to dig even a little bit layer down, Supermicro and Nvidia have been working together to deliver AI ML solutions for years now, and most recently the GB200 Oberon systems, which utilize Supermicro's systems with the Grace superchip technology in it. Supermicro is well known for delivering state-of-the-art GPU acceleration in their systems, but CPU-based servers as well as software-defined storage platforms. Recently, Supermicro teamed up with Data Direct Networks, or DDN, and has the ability to deliver the fastest time to market for AI, ML, and full HPC solutions. As workloads continue to evolve, how does this technology really help to solve those future challenges that we've been talking about?
Great question. So effectively, as you can see on the slide, everywhere that we plug in one of these partners' products, and especially with the capacity that Solidigm delivers, 61 terabytes, coming up very shortly, we can grow to these capacities that are required. The performance of each of the individual devices is critically important, and as networking grows beyond 400 gigabits to 800 gigabits and beyond, it's just going to carry this forward, and we're going to continue to develop these products along with NVIDIA. We've got great partnerships there, and it's just the wave that we're riding, and it's the solution that we're going to continue to keep coming out with, and for hopefully generations to come.
Yeah, I don't doubt that, to put it mildly. But CJ, let's bring you into the conversation here. What challenges do you see introduced by the new usage models, and what's some of the emerging tech that you're working on with these partners and others to address these challenges?
Thanks. Yeah, there are many things we could talk about. I'll just focus on two briefly. We've traditionally thought of GPUs as being compute monsters. They consume lots of data, but they really are cranking out solutions, and they're very compute intensive. For many of the new applications, they're not as compute intensive, but they're very data access intensive. And so you can actually begin to see the GPU as a data access monster. So you have hundreds of thousands of threads, each of which can be making their own access. So if you think about traversing a graph or a graph neural network, each individual thread figures out, based on accessing a large amount of data which may be in storage, too big to fit in memory anymore, and needing to bring that fine-grained data in and make decisions about, so what's the next node in this graph that I'm going to go visit? And all of those are making these concurrent accesses, which need to be packed and sort of pressed through a small number of PCIe pins to get to media. And so we have a new technology we're working on for SCADA, which is scaled accelerated data access for being able to do this. And one of the things that we really need and we rely on the media vendors for is to drastically increase the IOPS that we need to deliver that, and to be able to take those fine-grained accesses and do scatter-gather so that we can pass those across the PCIe bus as efficiently as possible. A second concern that we have is that of security. So all of us have a lot of our data in the cloud, and all of the compute infrastructure is so large that we can't afford not to share it. And so we have to be there at the same time. And there's a concern with storage as being one of the particular points of vulnerability of where lots of different tenants are accessing the same storage. The most compromisable place in the data center is where the user code is running on the compute node. So by being able to move the storage stack outside of the compute node into the more trusted infrastructure, for example, on a DPU, a data processing unit that's right there on the PCIe bus, and that we can effectively fit and power, thanks to Supermicro, for what we're doing there. We're looking then at some innovative storage techniques. We've been partnering with DDN, working on Nvidia as an example of something that can plug in at user level and to be able to transfer the file request over to the DPU and make it from there, where that Nvidia is operating on a proxy that's there. And that can significantly increase the security that you have throughout the whole system, because that unsecured node no longer has sort of free reign to get to everybody, because it's going through kind of the sheep's gate of the DPU. So those are just a couple technologies as examples.
Yeah, I think, again, security, it's a huge topic. We see it in the research that we do, that it's one of the primary reasons that when people talk about why they haven't figured out what they're doing with AI and ML, more in the Gen AI space, security and governance definitely comes up to the top. And I think these types of solutions where it brings security built in is key, to put it mildly. But Bill, let's bring you back in here. How is Solidigm really helping AI storage acceleration, and what does the future hold?
Yeah, thanks. Well, a couple things I want to note. Solidigm, first of all, has a pretty wide portfolio in terms of offering those set of products that kind of CJ talked about in terms of high throughput, low latency, starting with our SLC product, our 5810, all the way up to our QLC products like the 5336. CJ talked about the need for storage and even more storage, right? There may not even be enough storage for the amount of data that's kind of coming in, being collected. We're looking at even further advancing beyond our 61.44, right, in future, and expanding these capacities, right, to provide the density that you're looking for that TCO model, right? The other thing that we're doing is we're looking at, are we meeting the performance metrics of the application, right? We're looking at how the firmware is working with the ASIC and working with the NAND to optimize around quality of service metrics, around throughput, right, for these AI applications within each one of these stages. And there's a lot of secret sauce that we're putting in the firmware to sort of optimize around that. The other thing that we're thinking about too is that when we look at these Supermicro systems, we're looking at these latest and greatest form factors, right? The E3.S, even the E1.L. These EDSFF form factors are going to be needed going forward, right? When we talk about Gen 6, right, and PCIe, U.2 is no longer going to be able to cut it, right? So Solidigm has adopted a plan of really reaching forward and engaging in creating these new form factors, right? And ensuring that there's availability for these when we have products, and Supermicro has them out for customers that achieve high density, right, with the latest and greatest form factors. And then finally, I'll kind of sum it up. Kind of in the future, I talked a little bit about the form factors, but the other things you're sort of thinking about are, drives are largely block-based now, but one might think, are there different avenues and different ways in which we might be able to use these SSDs, whether it's zone namespaces, or we're doing something like an NVMe 4146, which is like a data replacement mode that's further optimizing the drive, enhancing endurance and capability and longevity, right? Because that's the other thing we're sort of missing here too is platforms, customers are wanting platforms and systems and drives to last longer and longer and longer. And so we're kind of thinking about that at Solidigm to say, hey, what are some of the things that we can do to enhance that reliability and that longevity?
Absolutely. I think it was touched on that also the TCO and the sustainability reasons for doing that and making it last longer and really moving through that is huge, especially with the water cooling and everything else that comes in to help with the efficiencies, because I think people have, again, HPC has been leading the way with this for quite some time, and I think that this helps other people know and understand where they're going to have to go with their other applications that aren't necessarily HPC sized. But Balaji, let's talk about like the AI workflows within a complete system and the data path from flash to GPU is the thread that ties your companies together. Can you discuss how collaboration is driving improvements in efficiency and performance for the AI data lifecycles?
Yeah, that's a great question, Rob, and it goes right to the heart of what all of us are trying to do here. And the great partnership we have is to exactly be able to do that. As use cases and data types explode, the goal is to make it simpler and abstract away the complexity from the customer so the customer can focus on running their applications and doing what they like to do best. So what we are doing here is working behind the scenes to abstract away all that complexity for the customers. And from the data management side, as CJ and Bill articulated very well, the goal is to be able to do it in a resource-efficient way, in a way with least overhead, with maximum performance, lowest latency, in a way that can maximize the utilization of all those GPUs deployed. So from a DDN perspective, we have implemented multi-tenancy, secure multi-tenancy, which is a way to make the most off of the infrastructure in a secure way that customers can depend on. And also to be able to we abstract away all the complexity of data management. So wherever the data is generated, whatever the source is, between that source to the GPU where you're running the applications, that entire data path is well optimized and secure and scalable. And just by installing a lightweight client, and the client is so lightweight they can even run on Raspberry Pi. So just installing that lightweight client on the compute side, it abstracts away all that complexity of data management and really delivers a low latency, high performance, and scalable way to handle all the data.
I like that, Raspberry Pis as part of HPC. I did not think we were going there today, but I think this has been really great. I think, again, one of the things that I note and is very interesting because we talked about it a little bit is that CXL is actually the next session that will be coming up, and how all of these technologies are coming together as a solution. What do you guys see? Last question. What do you see as like kind of the future goals for this from a density sustainability perspective? Because people are complaining about AI being unsustainable. What do you think? And we'll start with Balaji and we'll go around and end with Randy here.
Sure. There's a lot of there are different kinds of large language models at the moment, right? There's the large ones, the Chat GPTs and the Llama, which are built on hundreds of billions of parameters, if not trillions, right? Then there are smaller ones that are perhaps going to find application in a future smartphone, right? So regardless of the types, there's a need to optimize, for example, context windows, right? For a LLM on your phone, the context window is probably going to be smaller than the large language models, right, which run the Chat GPTs of the world. So to be able to understand the goal of each of these, right, and how they fit, what data types are you going to handle? Is it important to optimize for speed and latency, or have a larger context window and recall a lot more of your messages, right? So those kind of applications and use cases drive the need for the underlying infrastructure, right? And to be able to deliver those benefits to customers. And so what I see in the future is to be able to do more work to meet those kind of new and emerging applications that can fit a broader market need, right? Whether it's a consumer device, industrial, Randy talked about, maybe oil exploration or other industrial use cases, or automotive, self-driving vehicles, right? So many of these pharma, many of these applications to be able to cater and optimize to the goals of the customers and the applications.
Yeah, and I think, again, Bill, you were kind of getting at it. One of the things that we see is that density and power, a lot of these countries are talking about how they're running out of power and you got to get denser. And it seems like that's something that Solidigm is working on from a drive perspective.
Yeah, absolutely. We realize, right, the request, the mandate is that we really need to drive that TCO, the operational costs, the electricity that's used, the power that's consumed, right? To achieve that higher density per watt is first and foremost. And so we're looking to even create even higher density products, QLC based and other, to satisfy those requirements, also thinking about the power consumed. The other thing that's not often thought about is the weight that's consumed as well with legacy type media, right? You necessarily need to save on that. You talk about raised platforms and weight limitations and these kind of things. So offering extremely high density product that you can still fit maybe in an E3 form factor or something like that is certainly beneficial. And along with that, we're thinking again about the reliability aspect. Again, customers wanting even products to last longer. So we've been increasing even our MTTF metrics, right, to 2.5 million. That's an AFR of less than 0.4, right, percent, and that we're going to keep striving to go even further, right, to meet those metrics of reliability and sustainability.
Yeah, I mean, I think that the whole upcycling and circular economy aspect of sustainability a lot of times isn't thought about, but exactly what you're talking about, same form factors, same area. CJ, from an NVIDIA perspective, what are you seeing and what are you hearing from customers?
I think it's all about the data. So if you look at from an energy and power perspective, the less you can move the data, the better, right? And so having these dense systems where you can move data very quickly but don't have to move it so far, that's what's driving a lot of this, and that's what's needed to be able to drive down the energy costs and increase the efficiency with that. There's a technology called Magnum IO for multi-GPU, multi-node, and that pertains to data movement and access and management. And I think that there's a lot of innovation yet to come for how it is that we stage data, how it is that we maximize the total cost of ownership and what it is that we do. For example, DRAM is expensive, HBM is high bandwidth memory is more expensive, and if we can use cheap NVMe's and be able to maximize the rate at which we can access that, especially for these massive data sets that they just can't fit in memory anymore. That whole question about how we ingest and manage and stage data, I think, is going to continue to be an increasing concern. And there's it affects everything from your programming models down to the infrastructure, down to the underlying hardware.
Randy, last word.
Well, CJ really summed it up pretty well, and the usage model that I want to talk about is exactly that. So I've got customers today that tie together the HBM memory on all the GPUs through NVLink, right? And so they're taking, large amounts of HBM, but as CJ mentioned, that's expensive. If it's possible going forward to use something like CXL, which is going to be less expensive, again, tied together through these high bandwidth networks, it's one way to get those models into a lesser expensive technology, and of course the return on investment would be better than having to tie up all the HBM memory.
Well, I want to thank you all for being on, because this has been fantastic, and hopefully everybody who's been watching at home really gets an idea of why HPC has been really leading the way from HPC to AI. It's really been great. Thank you for coming on.
Thank you.
Thank you.
Thanks very much.
And thank you for watching, but there's a reminder that our next session, which we set up pretty well right now, is how CXL enables new use cases for storage and servers, which will air on August 29th at 10 a.m. Pacific time. Thank you for watching this episode, the new high-performance computing optimized storage from HPC to AI. Stay tuned for the next session.